Picture a single street photo with a huge truck right in front of the camera and, far in the distance, a tiny pedestrian just a few pixels tall. A detector has to find both in the same image at the same moment. That is the scale problem, and for years it was genuinely hard to solve efficiently. The old fix was to resize the whole picture into many copies, big and small, and run the detector on each one. It worked, but it was painfully slow. In 2017, a paper by Lin and colleagues introduced the Feature Pyramid Network, or FPN, and it quietly became one of the most reused pieces in modern detection. Today we're breaking down what it is and why it works so well. To really see the idea, let's follow the features as they move through the network, because FPN is all about combining two directions of information into one set of maps. This starts with an ordinary convolutional backbone running its normal forward pass. As it goes deeper, it naturally produces feature maps at several sizes. The early maps are large and detailed, wonderful for locating small things, but their meaning is still shallow, so on their own they struggle to recognize what an object actually is. Then comes the clever move. The deep, low-resolution maps carry rich semantic meaning. So we take those and upsample them back up, sending that understanding downward toward the higher resolution levels. This is the path that spreads strong recognition to every scale, not just the deepest one. Here the directions finally meet. Lateral connections fuse each upsampled deep map with a matching shallow map from the backbone. So precise location detail and strong meaning get combined at the very same level, right where the detector will read them. And the payoff falls out of that merge. Every level of the pyramid ends up semantically strong, so the detector predicts small objects on the fine, high-resolution levels and large objects on the coarse ones. One forward pass, and suddenly every scale is usable. Now, to appreciate why this matters, compare it against the way detectors used to handle a single feature map. Older detectors often predicted from just one deep feature map. That map was semantically strong, so recognition was fine, but it was also very coarse. Tiny, distant objects had almost no pixels left to work with by that depth, so they were routinely missed, and accuracy on small things stayed frustratingly low. FPN instead offers semantically strong features at every scale, cheaply, from a single forward pass. No more resizing the whole image many times and running the detector again and again. Small object detection improves dramatically, the pipeline stays fast, and the extra cost of building the pyramid is almost nothing. So let's pull out the three ideas that make this architecture click together. Combine both directions. FPN pairs the backbone's natural bottom-up feature maps with a fresh top-down path, so shallow detail and deep meaning flow together into shared levels instead of living in separate layers that never talk to each other. Lateral connections do the fusing. At each level, a sideways link merges the high-resolution detail with the upsampled semantics, giving you the best of both worlds without rebuilding features from scratch or paying for a second backbone. Strong features at multiple scales. The result is a pyramid where every level is rich enough for detection, so objects of any size, from tiny to enormous, land on a level that genuinely suits them and gets predicted well. All right, let's lock into 4 things worth remembering. Feature Pyramid Network solves scale and detection by combining bottom-up backbone maps with a top-down semantic path in one network. Lateral connections fuse high-resolution location detail with deep meaning, giving strong features at every level of the pyramid cheaply. Because it runs in a single forward pass, it replaced the slow older trick of resizing the whole image many times over. It became a standard neck and faster RCNN, mask RCNN, and RetinaNet, hugely improving small object detection along the way. If you enjoy having these ideas made simple, Standarity.com has a whole library of plain language AI explainers waiting for you.